Okay, so we're going to start by looking at prime factoring. Like we said, if we prime factor, we're trying to find all the primes that a number can be broken into. So we want all the numbers that are only divisible by 1 and itself that will multiply up to whatever number we are given. Yes, Yusuf? 2. 2 is prime. What else is prime?
4. 13. No.
4 is not prime because 4 is 2 times 2. What else, Olivia? 7.
13.
13. 3. 11. Okay, but there are also very bizarre primes. Okay, there are very large primes. Sometimes a prime isn't that simple number that you initially guess. So how do you check and know if something is prime or not? Okay, so this is what I tend to see with my students. They say, okay, if I want to decide if 101 is prime, they pick up their calculator and they divide it by 2, and then they divide it by 3, and then they divide it by 4, and then they divide it by 5. Do we remember some of those divisibility rules that we learned in previous grades? Like, how do we know if something is divisible by 2? It's even, right? So if a number ends in 0, 2, 4, 6, 8, we know it's even. It's divisible by 2. How do we know if something is divisible by 5?
It ends in 0 or 5.
It ends in 0 and 5? How do we know if something is divisible by 10? It ends in 0. How do we know if something is divisible by 3? Yusuf?
If it's divisible by 2 and 6. That's not.
Yeah, that would tell us, but there's an easier way.
Into multiples of 3.
I should say can be, but I don't want to write out divisible. The sum of the digits will be divisible by 3. So, for example, 111.
Yeah, 1 plus 1 plus 1 is 3.
1 plus 1 plus 1 is 3. Is 3 divisible by 3?
Yeah.
Yes. So 111 is divisible by 3. That same thing is true for 9. Okay, so for 9, the sum of the digits is divisible by 9. Now, worst case situation, you're right. You can pick up your calculator and you can divide and divide and divide. All right, just keep trying. That is fine. All right, but here are some quick checks that you can do without just having to guess in your calculator. I will tell you this. One of the most frustrating things to watch students do is to pick a number that they're not sure what it's divisible by. They try 1, they try 2, they try 3, they try 4, they try 5, they try 6, they try 7, they try 8, they try 9, and then they're like, ugh, I'm not going to find one. So then they like skip, and then they like try 14, and then they try 17, and then they try 25. And they start trying random numbers, and then they skip the ones that actually would work. If you're going to do it, just stick to it and keep trying the number that's next, so you don't skip the one number that would work. Okay? So we have our very simple prime factoring, or tree thingy, as most of you would remember it as, but this is actually prime factoring. So if we want to prime factor something like 40, we would ask ourselves, okay, what can we divide 40 by? Christian, what would you say? 10. Now, Bailey might pick 2, Christian might pick 10, someone else might pick 5. As long as you are mathematically correct, doesn't matter. You have to pick a correct one. So if we pick 10, 40 divided by 10 is what? 4. So if you're a calculator user, I don't care. I'd rather you be right and use a calculator than be wrong. You could pick up your calculator and do 40 divided by 10 equals 4. Okay, so now we'll look at these numbers. Can we split 10 up?
Yeah.
Yeah. What can we split 10
5
into?
times 2.
2 and 5.
And then 4 goes in.
Okay, hang on. Can we split 2 into anything?
1 and 2.
1 in itself, which means it's prime and we don't need to write it down. Can we split 5 into anything? 1 in itself, which means it's prime and we don't need to write anything down. Can we split 4 into anything? 2 and 2. So sorry those of you who have really atrocious, messy handwriting. This tends to be a little bit more tricky. You need to make sure that you can tell what's at the bottom of your tree. Now, it doesn't matter what level it's at. It just has to be all of the numbers that don't have a split coming off of it. So the 2 doesn't have anything below it. 5, 2, 2, right? None of those have anything below it. To help us in the long run, it's going to be best that we write this in numerical order, least to greatest. So we would say this prime factors into 2 times 2 times 2 times 5. So our prime factorization is 2 times 2 times 2 times 5. Very straightforward, right? You cannot write this as 2 to the 3rd power. I know we just talked about that last unit, but 2 to the 3rd power is not prime. 2 to the 3rd power is 2 times 2 times 2. So we'll write them all out. And we can prime factor with negative numbers. So what if we say, what's the prime factorization of negative 48? It's kind of simple right now. What types of negative numbers can we think of that are prime? What do you say, Christian?
Wait. No. Negative 2.
Negative 2 is not prime because negative 2 can be negative 1 times 2 and 1 times negative 2. So negative 1 is our only prime negative number.
Yeah.
So when you see a negative number, you can follow the negative all the way through. It's a pain in the rear. Most of us don't like to deal with the negatives anyways. Just get rid of that negative to start with and factor that negative 1 out. It's the only prime negative. So when you see that this is negative, pull out that negative 1 first and split it into a negative 1 and 48. It will make your life happier in the long run. Because then once you do that, then you just have to split up your 48. Okay, so what can we split 48 into? Sure, 6 and 8 sounds great. Can we split up the 6?
3 and 2.
Sure.
2 and 3.
What can we split 8 into?
2 and 4.
What can we split 4 into?
2.
Okay, so now even though we have numbers at multiple levels, again, as long as there's nothing coming off of it, it still counts as part of our prime factorization. So all of those numbers count. Anything with a branch off of it does not count. So we would say negative 1, 4 twos, and a 3. How could you maybe check and see if you're right? What would maybe be some options there? What do you think, Olivia? Multiply the prime factors back out. Now, obviously, if you accidentally left this as 4, you would still get the correct answer. So you do have to make sure they're all primes. But if in your calculator you put negative 1 times 2 times 2 times 2 times 2 times 3, you should get back out negative 48. Okay. Are we okay there? So how about 55x to the 5th, y to the 3rd?
You'll have to get rid of the exponents.
Yeah, so we got these variables over here we now need to deal with. So let's just ignore those for a minute. We haven't talked about what to do with those variables yet, so let's just ignore them. Let's just focus on the 55. What can we split 55 into?
5 and 11.
5 and 11? Can we go any further? Nope, sure can't, so we're done there. X to the 5th. What did we just talk about in our polynomials unit last trimester? How can we write x to the 5th?
5 times 5 times 5.
Not 5 times 5 times 5, but
Wait.
X times
x times x 5 times, right? So we can write this 1, 2, 3, 4, 5 times. So what would we do with our y to the 3rd?
Write it out.
Write it out.
3 times? Y times y times y? Does that make sense for prime factoring? Any questions on that? Okay, we're not done for the day, but we are going to